Any suggestions? Maybe there are some suggestions here. Okay, may I suggest? If you don't have it, I'm going to suggest. Think about the graph. Okay, did you get the hint? Okay. Look at
Professor,
that.
I think.
Go ahead.
I think bigger than 200. I think around
That's right.
240.
Bigger than 200, but I want you to go ahead. Do you see the graph?
I think 240, Professor.
Yeah, but we don't want exactly. The question is the number has to be less than 300 or bigger than 300? That's the question.
Less than 300.
That's right. That's right. But how would we know? We would just look at the graph. Look at the graph. Do you see that this is 5,000 here and this is 1,000 here? So look at the number 300 here. Look at the 300. Okay, can I enlarge? Let me try to, no, it doesn't allow me to enlarge. Okay, so if you go to the 300 here, around 300, before 300, actually, is this function increasing or decreasing after 0?
Decreasing.
Increasing.
It is increasing. So is it good to know that it is increasing? Is it good?
No.
No.
No. Is it good to know that?
Yeah.
Yeah, of course.
Yes.
It helps, right?
Yes, it's
Yeah.
Because I'm gonna look at the X300 and then I'm gonna look just before it. Of course, before it was small value, and after it is bigger value, and I'm looking for the better cost. Okay, less cost. So I'm gonna say by looking at the graph. Okay, let's write it in here if you like. By looking at the graph, okay, answer to the question C, I guess. Was it C? Let me see. No, it doesn't say C. Okay, so the answer to the last question is, okay, the answer to the last question can be found. Let's write the answer to this first, okay? X is equal to 300 is the least among 5. Okay, among 5. And now we are going to say the answer to the last question can be found, can be obtained, can be found by looking at the graph. Looking at the graph of the cost function. Yes?
Yes.
And then since C of x is an increasing function, after 0, after x is equal to 0, right?
Yeah.
The answer is okay. Let's copy paste from here.
Lesser than.
Least expensive. Let me copy this from here. So select text. Okay, copy paste. It is easier. Come on, open up. Doesn't want to open up.
You have to choose hand.
Oh, I see. How am I going to do that?
Just tap to hand on the left.
There's the hand. I cannot see the hand. How here? I see that. Okay, sorry. Okay, sometimes I don't see it. Okay, the answer is the least expensive location for print Q is less than 300. But let me try if I can make it bigger.
Yeah, it's now on 12. Yeah.
Okay, so that's the answer. Okay, is it difficult? Not at all. You just need to make use of all the tools that you know of. Okay, you have graphing, you have calculations, you can calculate, but try to choose the best you can. Let's take a break if you like, because we have almost two. Let's meet in 10 minutes. I'm gonna write here. So let's meet. Let me go back to where we were at. Okay, we meet at 2:10.
Teacher,
Okay.
can I
Okay.
ask something?
Okay, see you. Okay, let's continue if you like. It is 2:10, so we are going to continue with question 6. Okay, let me share it with you. Okay. Okay, so now question 6. Question 6 about FGR given functions, and we want to find the domain and range of each function, f plus g, f times g. F is given square root, g is given square root, and you guys know how to find the domain of a square root. You just need to look at the term inside the square root. It has to be greater or equal to 0. So easily you can find it. And the domain of f plus g is going to be the intersection of the domains, and domain of the f times g is the intersection of the domains, right? And the range, you know, for square root, it is 0 to infinity, right? The range is going to go 0 to infinity. So you can do it like that. So I'm going to just skip this. And I want to ask you this question. Question 7. The graph to the right shows the graph y is equal to negative x squared shifted to two new positions labeled A and B. Write equations for the new graph. So I want you to write equations for A and B in the chat. Can you write it for me, please? Okay, yeah, I give you just 1 or 2 minutes, and I want you to write it down. When you are done, can you say done so that I can go to chat? Because I'm I cannot see it from here. Anybody working on it?
Yeah, I'm working.
Okay, good. Okay, Batuan gave me an answer. A is equal to x minus 2 squared. And B is x plus 5 squared. Okay, this is good. This looks good, right? You are in one, you're shifting towards right, but Batuan, the function is minus x squared. Where's your minus? Yes, yes. Osan, yeah, your x is a, I guess, right? Okay, a is, yeah, minus, yeah. It's better to write x instead of a, by the way.
Okay.
And Osan, yeah. Okay, so I got 2 answers. Ahmed, are you gonna send it?
Yeah, either way.
Okay. So I'll wait and then we'll talk.
Done.
Okay. So Let's go back there to chat. Okay, yeah, Batuhan, yours is right now. Okay, Ahmed, in your case, you are shifting up or down, but this is shifting sideways. So it's going to be to the right, to the left. Okay, so Batuhan got it right. Oğuzhan got it right. Okay, so let me copy paste of Batuhan's. Copy, and then I'm gonna go ahead and write it here. Copy paste. Okay, so the answer is gonna be what is A? A is gonna be y is equal to this, and then we square it. We square it. Okay, but it doesn't square. Okay, did. Okay, and then the other one is, and B is shifting towards left by 5 units. So it's gonna be okay, and this is not timed, of course. I think he meant the power. Okay, this is the answer. Okay, that's good. Very good. Let's move down. And I want you to read this question. Graph the following function by starting with the graph y is equal to x cubed and applying an appropriate transformation, it says. And here is the function. Okay, let me copy paste. Okay, probably I have it here. Okay, so for this one, this is kind of different, right? Y is equal to x cubed, but we have 1 here, etc. Do you need a hint to start with? Do you want me to give you a hint? Okay, I'm gonna give you a hint in the chat. Okay, look at that. The hint is as follows. Hint is this one actually can be written as, look at that. Okay, just one sec. Do you hear it now? This is the hint. So do you see that I take out the -1? And this is something that you can recognize much better. Okay, so by looking at this, can you say, do you see that, what type of operations can you say? Like which one is right? Like reflection across the Y, horizontal stretch, horizontal, which ones should be included?
Horizontal stretch or compression. B.
Which one is gonna, or why did you think that way?
Because we did something to the x-axis. We did add minus or +1 to the x.
But this minus is not the horizontal stretch or compression. It is reflection, right?
Reflection.
Is it reflection? Right. If you put x in front of the function that we have, it's a reflection across the x-axis. Do you remember that? Let me see, just a sec. Okay, so here's the example. Okay, so for example, y is equal to absolute value of x. Reflection across x-axis is putting a negative in the front, right? You are making all y values negative. So this is a reflection example. Do you understand?
Yeah.
This is f and this is negative f. So you're reflecting across x-axis, all positive y values becomes negative value, etc. So it's going to be definitely reflection across the x-axis. which is D. And there's going to be a horizontal shift. Do you see that? Let me go over this here. Okay. Okay. This is the question. Which question was it? 6? Let me see. 8.
8.
Mm-hmm. Question 8, which is, this was given, but we just used a hint. The hint says, just take out the -1 so that it is something that we are aware of, we are familiar with. And then, so consider what we did to y is equal to x cubed. First of all, you see that there's a shift. Okay. By the way, towards
the right.
Towards right. That's right. That's right. Towards right. That's correct. By 1 unit, and also there's this -4 tells us that it's a shift down by 4 units, and this -1 actually it is the reflection of the shifted graph x minus 1 cubed. Okay, so you can change the order of this. Let's call it 1. Okay, and let's call this 2. Okay, 2. And let's call this 3. So you have 3 things, 3 transformations you do, but you can change the order of 1 and 2. You can first reflect y is equal to x cubed by multiplying with -1, and then shift it by 1 unit, and then shift down by 4 units. Okay, it doesn't matter the order here, but yeah, but you won't be able to shift the order of reflection with the shifting down by 4 units. Okay, it's going to be hard. So keep the shift down by 4 units at the end. Okay, so that's this order, and they match with the horizontal shift because we are doing shifting towards right by 1 unit. It's horizontal shift. Shifting towards right or left, it's horizontal shift. If you're shifting up or down, it's vertical shift. So we have C, we have E, and we have D, reflection across the x-axis, and that's all we have, okay? That's why we have answered. That's right, answer. C, D, E, let's put it in order actually. B, C, D, E. C, D, comma, E. Okay. Okay. That's the answer to this. Okay. Let's do number 9.
Can I ask something?
Sure.
Vertical stretch is beginning of the formula. Not -1. I thought it was like that, but you said it is. Can you open again the question?
Let's.
DCE, right?
Yeah.
Okay. D is reflection across the x-axis. And you said because of the -1, right?
That's true. That's true.
Okay, thank you.
Okay, if no more questions, then I'm going to skip. I'm going to start 9. Okay. Okay, so this is question 9. Answer, solution. Okay. Now let's see the question first. It says solve for the angle theta where theta is 0 to 2 pi, cosine squared theta is 2 minus square root of 2 over 4. It says use a comma to separate answers as needed. Type an exact answer. Pi as needed, it says. Now, whenever you see cosine squared theta, you should remember double angle formulas, okay? So the remember double angle formulas. What is the double angle formula here? Cosine 2x is equal to 2 times cosine squared x minus 1. This is one of the double angle formulas. I chose this because I have cosine squared x in it, okay? And from here, we isolate cosine squared x. We isolate cosine squared x from here, okay? All right, cosine squared x here. And then we isolate it by putting this 1 next to cosine 2x, 1 plus cosine 2x, and dividing by 2. We can isolate that. And then cosine 2x is this is, and then which is equal to, it says in the question, it says it is 2 minus square root of 2 over 4. This is given equation in the question, right? Cosine squared x is equal to this. But cosine squared x we found is 1 plus cosine 2x over 2. So we get such an equation, okay? Let me write it here. Okay. Let's write that. We converted the given equation to the following, okay, which is this. Now we are just focusing on this one now. We don't worry about the previous ones. Okay, so we just focus on this one. We are going to solve for x in the equation, in this equation, okay? All right. Okay, let me write this equation 2. Equation 2. And okay, what's my original equation? My original equation is, let me write that, copy, given equation. Given equation, equation, I call it equation 2. Oh, equation 1, sorry. Equation 1 is the given equation, which is this one. Let's see. Okay, let me write this like that. This is the given equation. I call it equation 1. Okay, I'm going to highlight that. And then I have the equation 2, which I convert equation 1 to a better equation that I can solve for x. Because it's difficult for me to solve for x in the first equation. Okay, this is easier to solve. Okay, this is easier to solve. To solve for x. That's why I did that. Okay, easier to solve. Okay, and I'm going to solve for x in the equation 2. Namely this equation. Okay, I'm going to solve it for x. And okay, I'm going to erase that. Okay, how would you solve it? You multiply both sides by 2. You get 2's are gone. I have 2 here left, and then I'm going to simplify this as 2 over 2 is 1 square root minus square root of 2 over 2. Okay, I write it like that. So I get 1 plus cosine 2x is equal to, simplified to 1 minus square root of 2 over 2. Okay, so I got this. I got this equation. Okay, I'm going to call it, if you like, equation 3. Equation 3. I got this equation 3, I should say. Okay, which is equation 3. Now I'm focusing on equation 3 now. Okay, in equation 3, I got the equation 3. Equation 3 is this. I'm going to just focus on this. Ones are going to go, cancel the ones. Okay, cancel the ones. Okay, after that, you this, okay. And how would you Hello. I am back.
Hello, teacher.
I think it's not. It is internet.
Problem.
In my other room, I think there's a problem. It just sometimes goes away. But in this room, it checks very well. So I came down. I changed the room. Okay. But I realized really late. Okay. So let's see. Where we left off. So we were talking about this, right? Let's finish it off.
Okay.
Let me see whether yeah, recording is continuing. Okay, perfect. I'm gonna let's see. Yeah, screen share. And okay, we were left off here. So we cancel it once, then we get cosine 2x is equal to negative square root of 2 over 2. Cosine is negative on the second and third quadrant. And you should remember all students take calculus, right? It just helps you. All of them are positive in the first quadrant. Sine is positive in the second quadrant. Tangent is positive in the third quadrant. And cosinus is positive in the fourth quadrant. So we use that. And then here 2x can be equal to, since this is square root of 2 over 2, we think about the 45. So it's negative. It should be 3 pi over 4. So 2x could be 3 pi over 4, and it could be 5 pi over 4 as well. 3 pi over 4 is in the second quadrant, and 5 pi over 4 is in the third quadrant, right? Okay, just a sec. Okay, so let me continue here. So we have 5 pi over 4, 3 pi over 4 is in the second quadrant, 5 pi over 4 is in the third quadrant. And then is this all? Not really. We have 11 pi over 4. When you just turn 1, 2 pi around, so you get 11 pi over 4. You get 11 pi over 4 as 2 pi plus 3 pi over 4, okay? And then we have 13 pi over 4, which is going to also cosine 13 pi, cosine 13 pi over 4 is going to also give us negative square root of 2 over 2. So why did we go like up to 4 pi? The reason is 2x could be searched for, searched in the interval 0 to 4 pi, because it's 2x. Although the question asks you to find x between 0 to 2 pi. Okay, that's why we had to go until, in the interval 0 to 4 pi. So 13 pi over 4 is actually bigger than 2 pi, okay? So we got all these, the rest of the 2 by just adding 2 pi to the answers we got here. And then next we solve for 2x. 2x could be 3 pi over 4. Here we get 3 pi over 8. 2x is equal to 5 pi over 4. From this one, we get x is equal to 5 pi over 8, excuse me. And then 2x is equal to 11 pi over, 11 pi over 4, we get x is equal to 11 pi over 8. And then the last one, 2x is equal to 13 pi over 4. From this one, we get x is equal to 13 pi over 8. So we got 4 answers, and all of these guys are between 0 to 2 pi. Maybe I should write it here, okay? All these 4 solutions, all these 4 answers lie in the interval 0 to 2 pi. Okay, so that's important. 0 to 2 pi. Okay, so and okay, if you just thought about the first 2 of them, so like 3 pi over 4 and 5 pi over 4, this wouldn't be enough. So we had to go further, and then that's the answer. So we got it done.
I have a question.
Mm-hmm. Go ahead.
I did a little bit forget about these pies, so can you please give me a little review about it?
About what?
The pies and the quadrant.
Okay. So let me go and get my graphic tablet. Okay, just 1 sec.
Okay.
Okay, I'm opening up the whiteboard. Okay, so I was saying that this is the first quadrant, second quadrant, third, and fourth. You can see my whiteboard, right?
Yeah.
Okay, so the answers would be like 2x. We would say we found 3 pi over 4. Okay, and then 5 pi over 4. And then 11 pi over 4, and then 13 pi over 4. Why is that? Okay, so first of all, let me draw another one here. Okay, this is 45 degrees. Yeah, this one is 45 degrees. You can consider. Look, if you go this way, this is the direction of an angle. So this is theta is equal to 3 pi over 4. And then we have 5 pi over 4, which is this. Okay, this is theta 5 pi over 4. Okay.
Yeah.
And then, and then what else? We have 11 pi over 4. Now, 11 pi over 4 can be obtained if you add 2 pi to this one. So it's going to go here, and then it's going to one turn, and then come back to here. I'm sorry. Maybe I should do it in another picture. Okay.
No. Okay. Not a problem.
Okay. So
just add 2 pi to theta.
That's right. So you go once, and then you come back to here. Okay, this is 11 pi. And it's still the same place, yeah?
Yeah.
And then similarly, you go once, and then you're going to come back to here, and this is the other one. This is still the same place, which is going to give you negative square root of 2 over 2. But we have to consider these guys because we have 2x here too. The question says find x in 0 to 2 pi, they say. But 2x is this much, and x would be whatever vx, just the 8 of all these guys are going to be the answer in 0 to 2 pi. They are going to be giving us the answer. So actually 2x is in 0 to 4 pi.
Yeah.
4 pi, yeah? Because it's twice of x. So we have to look for that much. Okay? So that's what I wanted to say. Do you need any further information?
No, thank you. That's all.
Okay. So I'm trying to get to where we left off. Okay, so let's share. I think time is up, I guess. Then what do we have? You should probably watch my, I uploaded my morning session. You can just watch the last, maybe last 40 minutes to see what else we did. I think, let's see what else we did actually. Let me see, 9 is, and 10, we talked about the 10. And what else do we have? Okay, these are the answers in here. You can find the answers here too. Okay. Yeah.
Are you gonna upload to your lectures for
Oh,
this?
yeah. I will send you guys the, there was a delay in that. For some, I was very busy first 3 days, and whenever I sit down to do it, something happened, and so because of that, there's a delay. But I'm gonna do that. Don't worry about that. But I want you to first focus on homework 1 and homework 2. Make sure that you guys understand homework 1 and homework 2. And then, so I will start sending you new videos, and then you will watch and move on, because we have to finish chapter 2 this week. So tomorrow you're gonna see chapter 2 videos finished, and chapter 3, I guess we should start. I don't remember the syllabus now, but we should start at this chapter 3. I might actually put more videos, even if we haven't covered that. Like I can tell you in the email saying that I'm putting like chapter 3 here videos, but we have not started. We are going to start in the 5th week, blah, blah. I can give you some indications about that, some information on that as well. Okay, so that's it. See you next week.
Professor,
next week,
can I ask
teacher.
a question?
Go ahead. Go ahead.
Just, I want
I still want you to actually look before. Who's asking?
Me, Salahuddin Said.
Salahuddin, I sent it in the email, and a couple of times, even if I add your name, you should find it in the group. So we have a group, right, in the mailing list. You should check all the emails that I sent. You're gonna find all the links.
I thought that you are going to upload them in the LMS system.
Yeah, they are also on LMS, and they are in the email as well. Okay. Week 2, I uploaded them. I can show you now. Do you want me to show you?
It's just for 16 seconds.
Is it?
Yeah.
No.
Oh. If there is a problem, then
I will check.
Are you speaking about the video in Teams, or
these are part?
I can also put it on Teams, actually, the links, if it is easier. I think Teams is the best.
Yeah.
I'm going to put everywhere, okay? I'm going to put on LMS. I'm going to put on Teams. I haven't put on Teams yet. I'm going to put on Teams, but I always email you guys. You should check the mailing list. And if there's, let me know, because maybe some sections videos could be not as perfect. I don't know. I don't have time to go over, check every one of them. I just quickly go over it, and if it looks okay, I upload it. So let me know if there are any problems with the videos, okay?
And we leave, teacher.
Okay, thank you so much, Professor.
Teacher, one last question.
Okay, go ahead. And I'll tell you before your question, let me tell you this. I still want you to write down the homework. Writing it down, even if you have the answers, is different. I want to see your handwriting, okay? I want you to handwritten. I want you to write it down, the homework. You have the answers I send you, like in the email, in the group here. But I want to see your handwriting and the way you write, explain things, etc. This is important for me. Yeah, go ahead.
Okay, when we will have to do the quiz and the last thing, the test and things like this.
Okay, probably I should put them all on the Teams as if it's an assignment, the dates. Maybe I should do that. It shows actually on the syllabus, the week shows. But maybe I should put it on Teams so that you're aware that when it's going to be, etc. Okay?
Yeah, in the schedule, yeah?
Yeah, I'm going to put it in. I'm going to share it on the Teams. And you're going to see like the assignment. It's going to show up like as if it's an assignment, quiz assignment. and you're gonna know the date, I guess. Let me try to do that on Teams if I can, as an assignment.
Okay.
But
Don't worry.
yeah.
Don't worry about it. I can go and check the syllabus. You don't have to trouble yourself with it.
Okay, thank you. Yeah, I will see if it works better for you. I will spend some time. Okay.
No. Take your time. Everything's possible. We have much time. You're a little bit busy, teacher.
Okay, thank you very much, Ahmed.
My
See you then next time. Okay, take care.
See you. Have a
Please
great day.
stay behind. You too. Bye bye.
Bye bye.